Dear students, today we are going to study about metallurgy. Metallurgy relates to the science and technology of metals. We have already studied about the properties of metal in lower classes. Metals are shiny, they are malleable, they are ductile. Metals are good conductors of heat and electricity. Then occurrence of metals. In the earth, in general, metals occur as a native element or in the combined state. Copper, silver, gold and platinum occur as native element because they have least chemical reactivity. In the combined state, alkali metals occur as combined state because they are having high chemical reactivity. Then now we are going to study about minerals and ore. What are minerals? What are ores? A naturally occurring substance obtained by mining which contains the metal in free state or in the form of compound like oxides, sulfide, etc. That is the substance which we obtain by mining the earth or excavating the earth is called a mineral. In the mineral, the metal may be in the free state or it may be in the combined state. Combined state means they may be present in the form of compounds. A metal may be a oxide, a metal may be a sulfide, a metal may be a carbonate, etc. In minerals, metal is present only in smaller amount. Ore means what? What is the meaning of ore? Minerals that contain high percentage of metal from which metal can be extracted conveniently and economically are called ores. Some of the minerals contains higher percentage of metals and that minerals are called ores. From the ore only we are extracting the metal by means of simple methods and economically it is very good for obtaining the metal from ore. In the percentage of metal in the ore is high. In simply we say all minerals are not ores but all ores are minerals. For example, we may take the ore of mineral of aluminium and ore of aluminium. China clay, it is a mineral of aluminium because it contains very little amount of aluminium. We can't extract aluminium from China clay. It is not economical, it is not simple, but we can extract aluminium from bauxite. It contains higher percentage of aluminium. So extracting aluminium from bauxite is convenient, it is simple and it is economical. This is the difference between mineral and ore. Extraction of metal from the ore involves 3 steps. The first step is concentration of the ore, second step is extraction of crude metal, and the third step is refining of crude metal. First we are going to study about concentration of ore. What is the meaning of concentration of ore? Removing gangue from the ore. What is gangue? The unwanted material or the impurities present in the ore is called gangue. What are all the unwanted impurities? The non-metallic impurities, the rocky material associated with the ore and the siliceous matter associated with the ore. What is siliceous matter? Siliceous matter means only sand or silica. So simply gangue means the unwanted materials present in the ore are called gangue. If we remove gangue from the ore, automatically the concentration of the metal in the ore increases. So concentration of the ore, once again I repeat, concentration of the ore means removing the gangue, increasing the concentration of the metal or its compound in the ore. That is called the concentration of the ore. For concentrating ore, we have 4 methods. The first method is gravity separation or hydraulic wash. Hydra means water. Here, this method is particularly used for concentrating oxide ores. For example, the native ore of gold is also concentrated by gravity separation process. Oxide ore of hematite, oxide ore such as hematite, tin stone, these are all concentrated by using gravity separation method. For this method, the first step is the ore is crushed into a fine powder, and then they are treated with a rapidly flowing current of water. Here, the ore particles are having high specific gravity and the gangue particles are having low specific gravity. By treating the finely ground or powdered ore in the rapidly flowing current of water, the ore which is having high specific gravity settles down. The gangue particles are the unwanted materials present in the ore. They have only low specific gravity. They are easily washed away by water. Thus, we separate the ore particles from the impurities by treating it with a rapidly flowing current of water. Once again, I repeat the process. Gravity separation or hydraulic wash. This is for the ores having high specific gravity, having the impurities having low specific gravity, and this method is especially used to concentrate oxide ores. And the method for contains the finely crushed ore is treated with the rapidly flowing current of water. Impurities are washed away by water. The heavier ore particles are settles down. Thus, we are separating the impurities from the ore particles. The second method is froth flotation process. Froth flotation process is especially for sulfide ores. Example for sulfide ore is galena. BPS is lead sulfide. Here, the metallic ore particles are preferentially wetted by oil. This is the basic principle behind this process. In this process, as I have already told, the ore is finely crushed or powdered. It is taken in a large tank containing water. The ore is added to the water or the ore is suspended in the water. Then we have to add a small amount of pine oil or eucalyptus oil. They act as a frothing agent. Then a small quantity of sodium ethyl xanthate is added. The sodium ethyl xanthate acts as a collector. What is the meaning of collector? It collects the ore particles and it rises to the surface as froth. Actually, the frothing agent is pine oil. Then air is blown to the mixture fastly, very fastly. The blown air agitates the mixture. The mixture contains water and oil. So, by agitating the mixture, froth is produced. Oil and water are agitated to produce froth. As I have already told, the ore is preferentially wetted by oil. So, the ore particles are associated with the froth and rises to the surface. We skim off the froth and collect the ore particle present in the froth after drying it. The gangue particles are preferentially wetted by water. They settles at the bottom of the tank. Then we have another question in our mind. If a sulfide ore contains a sulfide impurity, then what happens? Both sulfides are wetted by oil and both have the property of floating on the surface along with the froth. Then what we should do? Here, if the ore contains another sulfide as impurity, we have to add depressing agent. What are all the example for depressing agent? Sodium cyanide and sodium carbonate are used as depressing agents. They actually prevent the other metal sulfides from coming to the froth. Actually, the depressing agent depresses the floating property of the impurity sulfide. If we take galena, which is the ore, and if it contains zinc sulfide as the impurity, we have to add sodium cyanide as a depressing agent. It depresses the flotation property of zinc sulfide by forming a layer of zinc complex Na2ZnCN 4 times. The third method is leaching. Here, This method is based on the solubility of the ore in a suitable solvent and the reactions in aqueous solution. Here the ore is finely powdered and allowed to dissolve in a suitable solvent. The metal present in the ore is converted into a soluble salt or a soluble complex. The gangue particles remains insoluble. We have four types of leaching. The first leaching is cyanide leaching. By this method, by this cyanide leaching, gold ore is concentrated. The crushed ore of gold is leached with the aerated dilute solution of sodium cyanide. Here the gold present in the ore is converted into a soluble cyanide complex. Then from the soluble cyanide complex, we have to extract gold by using the metal zinc. Actually, the metal zinc displaces gold from its complex, and the zinc enters into the complex, and this process is called cementation process. Here the impurity aluminosilicate remains insoluble. By converting gold into a complex, and aluminosilicate is a gangue which is insoluble, it settles at the bottom. Next, ammonia leaching. Here the crushed ore containing nickel, copper and cobalt is treated with aqueous ammonia. They react with aqueous ammonia and they are converted into soluble complexes, and the impurities like iron 3 oxides and iron hydroxides and aluminosilicate are in the form of insoluble material and they settle at the bottom. Actually, in ammonia leaching, they are nickel, copper and cobalt are converted into their soluble complexes, and the impurities are in the insoluble form. Next one is alkali leaching. Here the ore is treated with the aqueous alkali to form soluble complex. The best example is bauxite, which is the ore of aluminium. It is heated with a solution of sodium hydroxide or sodium carbonate in the temperature of 470 to 520 Kelvin, and the pressure is 35 atmospheric pressure. Here the alumina, bauxite ore of aluminium, is converted into a complex sodium metaluminate, which is in the soluble form. Then this complex is treated with the carbon dioxide gas and we get hydrated alumina, Al2O33H2O. It is in the form of precipitate. It is filtered off and heated around 1670 Kelvin to get pure alumina. And finally, acid leaching. This is especially for sulfide ore such as zinc sulfide and lead sulfide galena. Here it is treated with the zinc sulfide is treated with the dilute acid, sulfuric acid. The insoluble sulfide is converted into soluble sulfate. ZnS is converted to ZnSO4. Zn is insoluble, ZnSO4. Zinc sulfate is soluble and it is dissociated into elemental sulfur. The fourth method for concentrating ore is magnetic separation. This magnetic separation is especially for ferromagnetic ores. This is based on the difference in the magnetic properties of ore and the impurity. For example, we may take tin stone and wolframite impurity. Usually the tin stone is associated with the wolframite impurity. The ore tin stone here is non-magnetic and the impurity is wolframite is magnetic. Let us take another example also. Chromite and pyrolusite are ores having magnetic property, and the impurities present in this siliceous impurities are non-magnetic. The crushed ore is poured on to an electromagnetic separator. This electromagnetic separator is having two rollers. It consists of a belt moving over the two rollers. One of the roller is magnetic. If we pour the crushed ore and it rotates along the roller, the magnetic part of the ore is attracted by the magnet and falls as a heap close to the magnetic region. The non-magnetic part falls away from the magnetic region. We have two examples. If you take a tin stone and a wolframite impurity, here the impurity is magnetic. It is attracted by the magnetic roller and it falls near the roller. Tin stone being non-magnetic is not attracted by the magnetic roller and it falls away from the magnetic region. Thus, we separate the magnetic and non-magnetic part present in the ore. Thus, we have four methods for concentrating ore. First method is gravity separation, the second method is froth flotation, third method is leaching, and finally the fourth method is magnetic separation, which is especially for ferromagnetic ores. The remaining, that is the extraction of crude metal, we see in the next class. Thank you.